Hey guys, welcome to my course on Ansible. I'm delighted that you gave me this opportunity to guide you on your path to become an automation expert. We will start off with understanding the basics of automation, such as what is the need of automation in today's enterprises and how you can start on your automation journey. Then I will tell you the basic principles of DevOps and where does Ansible fit in it. Then I will give you a bird's eye overview of Ansible without going into too many details. After which, we will set up our lab, which we will use for the duration of this course. Next, we will start writing our first playbooks, use various modules to accomplish complex tasks very easily, and understand how you can gain privileged access on the remote systems. Then, we will understand how you can set up your own event handling system in Ansible using handlers. We will finish off this section by doing a little project. After this, we will take a deep dive in inventory management. We will talk about group and host variables and how you can organize your inventory. We will then talk about how you can organize your playbooks using import, include, and roles. Next, we will talk about various variable types in Ansible and how you can use them using techniques like register. After that, I will show you how you can gather information about remote systems and use it in conditions. We will finish off by understanding Ansible Vault, which is a technique to safeguard your sensitive information in Ansible. Now a bit about myself. My name is Vikas and I have been in IT engineering for over 12 years now. Over this time, I have worked in various technologies like networking, system management, DevOps, and more recently, cybersecurity and big data. In the end, a small note from my side. Please leave your feedback at the end of this course, as it helps me improve the quality of my content and keeps me motivated. With this, we've come to the end of this section. I will see you in the next. Bye. Hey guys, in today's world, IT operation teams manage ever-changing complex IT architectures built on multiple platforms and complicated technology stacks. Some of the issues that organizations face in today's ever-evolving landscape are unconnected management tools, making it hard to manage your applications and data. Complex scaling procedures that make it difficult to scale up or down based on demand. And inconsistent policies and processes could also add to the overall complexity. Now, IT automation helps you resolve some of these issues. IT automation is the act of automating a manual process. For example, you might need to do a monthly restart of some of your servers. In the traditional world, this would require a human to log in and perform the restart based on the number of servers. This could take a lot of time. For example, I once had to patch and restart 60 servers. I had to log into each one of them, run the update command, wait for it to finish, and then reboot the server. All this would take me roughly 5 to 7 minutes on a single server, and if you multiply that by 60, by the end of 5 hours, I'd look like this, banging my head against the table. This time could be brought down considerably if you automate the tasks. Now, what are the benefits of automation? You can improve the overall infrastructure performance and compliance by maintaining a consistent configuration of your applications, by detecting and maintaining appropriate patch levels, thereby increasing the security of your system. You can also increase the efficiency and consistency of your operations and processes by automating manual tasks and minimizing human errors. You can also gain an understanding into your workloads by understanding the dependencies between various systems and processes, and also by anticipating capacity requirements, which eventually help you to auto scale seamlessly based on demand. And therefore, you can increase the overall performance and availability of your system with the help of automation. Now, all this is well and good, but how can you start with automation? Well, it's very easy. All you have to do is identify a single manual process in your organization that is very easy to automate. Once you've identified that single manual process, for example, let's say restarting servers, You then automate that single process by using automation tools like Ansible. Now, once you've successfully automated that single manual process, you can then rinse and repeat the same process. So you can pick a second process, let's say patching, automate that, and then go on to pick the third process. Now, I hope you've understood why we need automation in current IT world. With this, we've come to the end of this lecture. I will see you in the next one. Bye. Hey guys, before we start off, I want to introduce a few concepts so you can start on a sure footing. Let's start with DevOps. In the earlier days, you had different teams for developers and system administrators. A developer's mindset was more focused towards developing the product and pushing the code out to production as fast as possible. Now, this would sometimes be in conflict with the mindset of a system administrator because system administrators were more focused towards running the operations as smoothly as possible and maintaining system uptime. Now, DevOps as a methodology relies on increased collaboration between the developers and the operations staff. Thus, the dev in DevOps is for developers and the ops is for system administrators. It achieves this collaboration by automating as much as possible. Now, there are three primary areas in DevOps. Infrastructure automation, where you create your system OS configs and app deployments as code. Continuous delivery, where you build, test, and deploy your apps in a fast and automated manner. And site reliability engineering, where you operate your systems, monitor and orchestrate them, and also design them for operability in the first place. Now, if you are interested to know more about DevOps, I would recommend you to go on the internet and research about DevOps and agile methodologies. With this, we've come to the end of this lecture. I hope you liked it, and I will see you in the next one. Bye. Hey guys, another topic I want to tell you about is configuration management. It is simply an automated method of maintaining the state of your computer systems and softwares. There are several components in a configuration management system, which include servers, storages, networking, and software. The goal of a configuration management tool is to maintain these systems in known determined states. Another aspect of configuration management system is that you can describe the desired state of your system. And the third aspect is the use of automation software tools to ensure that target systems are maintained in the desired state. The primary benefit of configuration management is that your systems and softwares are always consistent. With configuration management, you can ensure that your configuration is correct because the configuration management system ensures that it is correct. It also allows you to scale your infrastructure and software system quite easily based on demand. Now, some common configuration management tools are Red Hat Ansible, Chef, Puppet, etc. Now, if you're already working in IT, you might have heard a similar term, change management. Configuration management and change management are two closely related but different terms. Configuration management deals with the state of any given infrastructure or software system at any given time. Change management deals with how you make changes to those configurations. Think of it this way. Configuration management is the configuration at any given time, for example, the various settings of an application, and change management is the process for proposing, reviewing, implementing, or potentially rolling back changes to those application settings or configurations. With this, we've come to the end of this lecture. Thank you for watching. Bye. Hey guys, configuration management tools follow two different architectures to achieve their objectives, pull-based versus push-based. In a pull-based architecture, you have a master server which stores all the configuration information, and then you install agents on each of the server for which you want to manage the configuration. In this architecture, the agent will regularly poll the master server to check if there are any changes. Tools like Puppet and Chef use pull-based architecture. It is called pull-based because an agent pulls the configuration information from the master server. Now compared to pull-based, in a push-based architecture, a central server pushes the configuration changes onto the target systems. Ansible is push-based. In a pull-based system, clients contact the server independently of each other. Therefore, the system as a whole is more scalable than a push system. However, the downside is that you need to install and manage an agent on each of the target systems. Now, in a push-based system, it is very easy to do the initial configuration as you do not need to manage or install an agent. However, once you start scaling your infrastructure, things start to get complicated and you start seeing performance issues unless you do stuff like hyperthreading, etc. Now, there's one more entity I want to talk about. It's called a version control system. For example, Git. This version control system helps you version control your code and makes it easy for you to roll back your changes. Now, in development environments, all the code and configuration will be stored in this version control system, and the master servers, whether it is push based or pull based, will continuously poll the version control system for any changes. Therefore, the information or code gets stored in the version control system, gets version controlled, and then the master servers poll the version control system for changes in the code, and then once they receive any changes based on the architecture, the agents will either pull from the master server or the master server will push those changes onto the target systems. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, let's talk about Ansible in this video. Ansible is an IT automation, configuration management and provisioning tool. It helps you describe an IT application infrastructure in something called playbooks. It provides you with a simple automation language to write the playbooks, and it also provides you with an underlying automation engine to run those playbooks. Some of the features of Ansible are: it is agentless, so you do not need to install an agent on the server and you do not need to also manage an agent. It uses SSH to establish secure connection. It follows push-based architecture. It is built on top of Python, so it has a lot of functionalities of Python inbuilt. Now let's have a look at a basic architecture of Ansible. Now we have a master server which stores all your configuration install information and can also run Ansible playbooks. On this master server, we have an inventory file, and this file contains a list of all the servers against which you want to perform some tasks. For example, patch updates. Now these tasks are grouped together in what is called a play. So a play is nothing but related tasks that you need to perform on a server. This play is stored on what is called a playbook. So again, a playbook has a play, and a play is separated into multiple tasks. For example, you might want to perform a patch update on your servers and then reboot your servers. These are two different tasks. So task 1 in your play will update the server and task 2 in your play will reboot the server. These two tasks together will be called a play, and the play will be stored in a playbook. Now lastly, we have the servers where you want to run these plays against. Ansible master server will SSH into these servers and then execute the task. These playbooks are written in YAML, which is an acronym for YAML Ain't Markup Language. We'll talk about YAML in an upcoming lecture. With this, we've come to the end of this lecture. I will see you in the next one. Bye. Hey guys, let's talk about some basics of YAML in this lecture. YAML is basically a human readable structured data format, which means it is a format to store structured data. Now what is a structured data? A structured data is some data that has a structure around it. For example, all the books on your library can be structured with the book's title, number of pages the book has, the price of the book, and author. And structured data helps us recall that data quickly with the use of the structure that we put around that data. Now there are some rules around YAML that we should know. YAML files end in .yaml. YAML is case sensitive, and YAML does not allow the use of tabs. It uses spaces instead, as tabs are not universally supported. Now let's have a look at some of the data types in YAML. YAML excels at working with mappings, which are nothing but hashes or dictionaries, sequences, which are nothing but lists, and scalars, which are nothing but strings or numbers. So this is a typical YAML file. It ends with .yaml as extension, and then we've got 3 dashes that denote the start of a YAML file. You can put a comment inside a YAML file by typing hash symbol, and then anything after that hash symbol is a comment. Now this is an example of a scalar of different types. So title is a scalar of type string. But what is a scalar? Scalar is nothing but a variable. So it can hold multiple values. Now what is a variable? It is a placeholder that stores some information. So I've got title that stores a string, pages that stores an integer, price that stores a float, and for sale that stores a boolean value. Now you can also have sequences in YAML, and a sequence is nothing but a list. So for example, here I've got a sequence which has toy and animal at single level. Now you can also have nested sequences. Now in nested lists or sequences, how you nest them is by using a space before the value. So I've got a value of toy here which I've put in by typing in a dash and then space and then the value. Now to create the next level, what I've done is I've used a space and then dash and then space and then a value after that. So with the use of this space here, I've created a nested sequence. Now a mapping is nothing but a key value pair. So it has a key and that key has a value. So for example, drink is a key and the value for that key is cold drink or cold underscore drink. Now in mappings, you can also include sequences. So in this example, cold drink or cold underscore drinks will be a key and the value would be a sequence. So we have 3 values inside that sequence. Now this could also be a nested sequence, so I can even go and put Pepsi Max here. So to do that, I will need to type in at the same level, I need to type in a space first and then dash and then a space to create the next value, and then type in, let's say, Pepsi Max, and this will create a nested sequence. Now next is a flow collection, and flow collection is nothing but a key value pair where we have multiple values for a single key. So we have fruit as the key and it has square brackets to start a flow collection and then multiple values for fruit separated by a comma. And then to denote the end of YAML file, I've got 3 dots. So this is a structure of a YAML file. This is not a YAML course, so I would encourage you to go online and study YAML if you like. With this, I've come to the end of this lecture. Thank you for watching. Bye. Hey guys, if you have made it this far, I congratulate you on your progress. We are done with the initial theory and can get our hands dirty now. Here on the slide, I have the architecture of the lab that we'll set up on our computers. We will use VirtualBox as our virtualization engine. I will set up 3 virtual machines. One of them will be the master server where we will install in Ansible. We will also have 2 client machines where the server will push the configuration changes. I have specified one of the client machines in production environment and the other in development environment. This will simulate the real world scenario where you will have to deal with multiple environments and your changes will need to be pushed to lower environments first, such as a development environment, before they can be pushed to production environment. This is to keep the production environment error free. Now each of these virtual machines will also have 2 network adapters attached to them. First will be a bridged adapter that will be used to communicate with the internet to download updates and any other software. This adapter will have a DHCP assigned IP address. The second adapter will be used for inter-virtual machine communication. So for example, when Ansible master server wants to SSH into any of the client machines and run any automation scripts, it will utilize the host-only adapter. The host-only adapter will have a statically assigned IP address in the range of 192.168.56.x. In the next few lectures, I will show you how to install VirtualBox on Windows and then create your first virtual machine and install Ubuntu Linux on it. After that, I will show you how to clone your virtual machine. What I want you to do is to create one virtual machine, install Ubuntu, and then clone the other two virtual machines in the setup. With this, we have come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Welcome. In this lecture, you will download and install VirtualBox on a Windows 10 host operating system. So to start, you will need to go to https://virtualbox.org. That should take you to this page. Once here, you can click on Download VirtualBox, and that should take you to the Downloads page. On the Downloads page, you will see a list of packages for different host operating systems. Because we are installing it on a Windows host, I'll click on Windows hosts. But if you're doing it on Linux or Mac or Solaris, you can choose those. That should automatically start the download, but I'll cancel out of it because I've already downloaded VirtualBox. Once you've done the download, then you need to go to your local file system where you've downloaded this package. I've done it right here, and then double click on the package. That should start the installer, and you can click next here, just next here as well. You can click yes and then install. That should start the installation. Now it's asking me to provide my admin username and password, so I'll click yes here, and that should start the installation right away. This is a pretty quick installation, so we'll just wait for it to complete. I think it's almost done. You can also download other things for VirtualBox if you like its SDKs, some extension packs. Meanwhile, the installation is finished, so I'll click on finish. I'll untick this first because I don't want VirtualBox to start right after my installation, but if you want, you can keep it clicked and it will start the application right away. I'll click finish here, and I can see that the VirtualBox icon is here. So this is it for this lecture. Thank you for watching. Alright, time to create your first virtual machine. You can do this by first going to VirtualBox Manager, which is the application you'll use to install and manage your virtual machines. You can create a new virtual machine in three ways. You can click new here, or you can go to machine and then click new, or you can type in Control N from your Windows machine. So I'll click new. Here I need to give it a name and specify what operating system I will install on this virtual machine. So I can type in Windows and it will automatically type the type and version information, or I can type in Ubuntu and it should change the type and version to Ubuntu. So we'll be installing Ubuntu for this demo, and I'll click on next. Oh, it's giving me the error because I already have an Ubuntu, so I'll just call it -1, and I can click on next. Here I need to give it some memory, so I can do that by either moving the slider, or I can install memory by typing it in here. So I can say 2048 and it's gonna give it 2 GB of RAM. Now, a small note, you should never allocate more than 75% of total resources available for your host to all the virtual machines running simultaneously on your host. For example, If I have a laptop which has 8 gigabytes of memory, then I should not allocate more than 6 gigabytes to all the virtual machines that will be run simultaneously on my laptop. If I do that, I could experience slowness, system crashes, or some other errors. But I've got an 8 gig machine and I'm just allocating it 2048 MB or 2 gigabytes, so I should be fine. So I'll click next. Now if it is asking if I already have a virtual disk or if I want to create a new one, I need a new virtual disk. So I'll click create. Now it's asking me to tell it the file type I want to use. There are three options: VDI, VHD, VMDK. VDI is the native file format for VirtualBox. VHD is supported by Microsoft and VMDK is supported by VMware. Now, if you want to go for VHD or VMDK, you might experience that some features are either not supported or not available on VirtualBox. So I will leave it as VDI for now and I'll click on next. Now I need to specify the storage type. There are two storage types: dynamically allocated and fixed type. Dynamically allocated will only use the space as it consumes. So even if I have, let's say, allocated 32 gigabytes to my virtual machine, but I'm only consuming, which means I only have files worth 10 gigabytes on that virtual machine, it will consume 10 gigabytes on the host machine. Whereas in fixed size, if I specify 32 gigabytes, it will always consume 32 gigabytes. It takes a bit of time to set up a fixed size hard disk, but once it's set up, in some scenarios it is faster to use. For the purpose of this demonstration, I'll keep it as dynamically allocated and I'll click on next. Now I can specify where I want to store my hard disk. It is generally stored under your username, VirtualBox VMs, and then your VM name. That's the default file path for VirtualBox to store their virtual machines. But if I want to change it from the default path, I can specify it. So let's say if I want to save it under my OneDrive, I can go OneDrive and save it under there. But I don't want to do it, so I'll cancel out of this. Here I can specify the storage space allocated to this virtual machine. I'm going to give it 32 gigs and I'm going to click create. Now it has created my new virtual machine, and what I can do now is I can go settings. Again, three ways: I can right click and click settings, or use the settings icon up at the top, or I could have gone machine and then settings. So machine and then settings. Here I need to go to storage and then I need to click on this empty CD icon, which will take me to the optical drive, and I need to click on this little CD here and then choose virtual optical drive, and can then need to specify the ISO. Now this is akin to putting your operating system CD in the optical drive of your physical machine. Now I can click OK now, and I can click start to start the installation of Ubuntu. Now for those of you who do not have an operating system image ready, what you can do is you can go to ubuntu.com/downloads/desktop, or you could go to ubuntu.com and you can download a copy of Ubuntu from here. So you've got various options. If you click on Ubuntu desktop, which we will be installing in this demo, you can then click download here. It is a free open source software, so it is good for your lab systems and in some cases production systems as well. Now our virtual machine is booting up. One thing to note here is that this little piece of information, this is called the host key. Now what normally happens is If you have an operating system that does not support mouse pointer integration, and you're doing something in the guest operating system, and your mouse is captured by the guest operating system. Now to get the mouse back onto host operating system, I need to click on this host key. So if this was an operating system that would not support mouse pointer integration and I'm in here, then I need to click on right control to get out. So for example, you're doing something here, right? You're typing something on the browser, you're clicking something, or you're just playing your YouTube videos and just going through the playlist. Now you want to come out of that machine and shut down because you've completed your work. You'll have to click right control and you'll get control on the host operating system. So from here, back into the installation, we need to choose the language. We leave English as default. Then we can click on install Ubuntu. And that should start the installation. Now we need to choose the keyboard layout. We'll leave it as default. We can click on continue. Now we can either do a normal installation, so it's going to install some web browsers, utility, office software, games, media players, all those things, or I can just do a minimal installation, which is faster, but it's going to get installed less number of items on my machine. But I can always download and install these later if I want. Download updates. We'll download some updates while it's installing, so I don't have to update my system after installation. I could also install some third-party softwares for graphics and high Wi-Fi, but I'll leave it in minimal installation and then I'll check that, and I can click on continue. And it's asking me if it wants to erase disk and install Ubuntu. Because it's a new disk, we can click that. If we wanted to partition the disk, we could have gone something else and we could have partitioned the disk, but I just want to erase disk now. So remember, this is not the host operating system disk. This is the virtual hard disk we allocated for this virtual machine. So it's going to use the free space on my host operating system anyway. So I'm going to click continue. And that's my time zone correctly, so no problem. Need to specify a name here and password. Oh, I had the caps on. Now passwords are really important for the machines that will be connected to internet, so make sure you've got a secure password. If I click on login automatically, it's going to log me in automatically every time. If I say require my password, this is more secure. So if your machine is connecting to internet, just make sure you require a password every time to log in. It's a bit of an hassle, but it's more safe and secure. Now it's starting the installation. What I'll do now is I'm going to pause the video and I will resume once it's finished installation. Alright, welcome back. So Ubuntu is installed on my virtual machine, and what I can do now is I can safely shut down the virtual machine, or I can either keep using it. So that's it for this lecture. Thanks a lot, and I will see you in the next one. Bye. Alright, welcome. In the previous lectures, we installed VirtualBox. We created our first virtual machine, installed Ubuntu desktop on it, and we talked about snapshots. The next feature I will talk about is clones. A clone is a duplicate copy of your virtual machine. There are two types of clones, a full clone and a linked clone. A full clone is an independent copy of a virtual machine that shares nothing with the parent virtual machine. Ongoing operations are completely separate. But the disadvantage is that it could take some time to create a full clone. The second type is a linked clone. A linked clone is a copy of a virtual machine that shares the virtual disk with its parent in an ongoing manner. This conserves disk space and allows multiple virtual machines to use the same software installation. In this mode, a new differencing image is created where the parent disk image is the source image. If you selected the current state of the source virtual machine as a clone point, a new snapshot will be created implicitly. All files available on the parent at the moment of that snapshot creation will continue to remain available to the linked clone. But ongoing changes to the virtual disk of the parent do not affect the linked clone, and changes to the disk of the linked clone do not affect the parent. Some benefits are that it conserves space and is created a lot quicker than a full clone, but you cannot power a linked clone if you do not have the parent VM. Also, performance may degrade over time. So enough with the theory, let's see how it's done. It's very easy. All you have to do is you need to open up Oracle VirtualBox. Select the virtual machine for which you want to do a full clone or a linked clone. Right click, you can do Ctrl O, or you can select clone from here. You can name your clone. You can reinitialize the MAC address, which will assign a new MAC address to your network cards. Click next. You can choose a full or a linked clone and click next. You can choose what to clone. So current machine state will clone everything except the snapshots created on the parent virtual machine. Everything will include the snapshots as well. So for now we'll just do current virtual machine and click clone. That should start the clone operation. I'll pause the video now because it is going to take about 5 to 7 minutes for it to finish. So that's our full clone done, and as you can see, even though our parent virtual machine had snapshots, because we chose the current state, our clone does not have any snapshots. Now to create a linked clone is similar in procedure. So for example, that's my linked base, that's my parent virtual machine from which I created a linked clone, and this is my linked clone. But I can just remove this linked clone and I can use this, click on clone, or I can choose any other virtual machine like this one, click on clone, name it, initialize the MAC address, call it a linked clone, and I can click on linked clone. And you can see that creating a linked clone is actually very fast. Create the linked clone straight away because our new linked clone is sharing the disk with this. We can create another linked clone and that will also be fast. Okay, we just have to change the name. So I'll go clone 3, reinitialize MAC address and click on next, linked clone, and see that linked clone is really fast because now these two virtual machines are sharing the hard disk with the parent virtual machine. So that's it for this lecture. Thanks a lot. Bye. Hey guys, hope you have created 3 virtual machines and named them. If not, go back and create those virtual machines now. In this video, I will show you how to establish connectivity between your VMs. We will use 2 network adapters, one bridged and one host only, to establish connectivity. We will use the bridged adapter to communicate with the internet, and the host only adapter will be used for inter-virtual machine communication. Now let's go back to the VirtualBox Manager. Now in the VirtualBox Manager, first I want you to go to Global Tools and Host Network Manager. Here I want you to double check the configuration settings for your host only network. Under VirtualBox Host Only Ethernet Adapter, I want you to go configure it manually, and then under IPv4 address I want you to type in 192.168.56.1. This is because if we go back to the slide, we are going to use 192.168.56.x network. So we need the host only adapter to be in this IP range. Now the network mask is 255.255.255.0. The next thing I want you to do is go to DHCP server and make sure that this is disabled. Once you've done those two things, you can hit apply to apply those changes. After that, you can click on machine tools to go back to the virtual machines and right click on any of the virtual machines and click on its settings. Under general and basic, you can rename the virtual machine to what I have got on the screen, so master, prod and dev. And then under advanced, if you want to enable bidirectional drag and drop and shared clipboard, you can choose those settings. This is so you can copy and paste from your host machine into the guest machine, and you can drag and drop files into your guest machine as well. Once you've selected those two settings, you can go into networks and you can make sure that there are two adapters attached to this virtual machine. So the enabled network adapter box should be ticked for both of these. The first adapter should be a bridged adapter and the second adapter should be a host only adapter. Once you've verified those two settings, we can hit OK and then we can hit start on that virtual machine. Now after the virtual machine is up, you can go into the terminal for that virtual machine, and the first thing we'll need to do is we'll need to set the host name of that virtual machine. Now what happens is when you clone virtual machines, the new clone takes all the settings from the original machine, which means the host name will be similar to the original machine's host name. Therefore we'll need to set it. And to set the host name, we need to type in sudo nano or any other text editor you want to use, and then we are going to edit this file /etc/hostname file and hit enter, and then type in the password for sudo. And here you can change the host name to whatever you want. So for example, this is the prod server, so I'm going to call it prod.testlab.com. Let's double check from this slide. So the prod server is actually prod.testlab.com. Now we can save the file and let's just double check that it has taken those changes. Yep. Now the next thing I want you to do is we need to set the static IP address for this machine. So nmtui. This command will open a network connection editor. So nmtui and hit enter. And once the new dialog box open up, I need you to click on edit a connection and hit enter. And then we are going to edit the wired connection too. So select that and hit enter. Now under wired connection 2, I want you to go into IPv4 configuration and select the automatic next to it and hit enter. This will open up a drop down box, and from that drop down box we are going to choose manual, and we're going to go right and click on show. From here we can type in the address for this machines, and because this is the prod box, the IP address for prod box is 192.168.56.10. So let's go ahead and type that in. So once you hit enter, so we can type in 192.168.56.10, and the gateway would be 192.168.56.1, and we can go all the way down and hit OK and back. Now we can click on activate a connection, go to wired connection 2 and hit enter once. This should deactivate the network adapter, and then if we go there again, we can see that it says activate now. We can hit enter one more time to activate this, and this should have taken the new IP address. Now we can hit quit. Now if we do an IP ADDR show, this should actually tell us the new IP address. So as you can see, it has taken the IP address 192.168.56.10. Now for this machine to take the new host name, we can reboot the machine. So let's type in reboot, and let's head back to the second machine. So we're going to go to prod. Let me minimize this. Let's log into the prod machine. On the prod machine, we need to repeat those same steps. So let's open up the terminal. Now on the terminal window, first we need to set the host name. So sudo nano /etc /hostname, type in the password and change the name to master.testlab.com. Control X, save it, and then we need to type in, what I will do is I will set the IP address here through GUI, so you know how to set the IP address through GUI as well. So you click here next to the battery icon and then click on settings, and this should open up the settings box. Once the setting box opens up, you can go all the way down and click on network, and this will open up the network editor. On the network editor, we can click on the settings next to the second wired adapter, and there we need to choose IPv4 and select manual here, and then we can type in the details. So under addresses, we need to type in the address for the master box, so 192.168.56. Let me cross check with the slide, 56.100. So going back, 56.100, and then the network mask is 255.255.255.0, and then the gateway is 192.168.56.1. and now we can hit apply, and then we can turn it on. And again we can go to our terminal window and type in IP ADDR show for it to show the new IP address. So as you can check, it has taken the new IP address. So let's reboot this machine as well, and let's head back to the dev machine. Now we're going to repeat those steps on the dev system as well. So sudo nano /etc /hostname, and then the password, and then we need to go change the hostname. So this is dev, so dev.testlab.com. Control X and yes. Now the next thing is nmtui, edit a connection, wired connection 2, and then automatic to manual, then click on show, and then we need to type in the IP address, so 192.168.56.1, and the gateway would be 192.168.56, my bad, 168.56.1, and we can go all the way down, click on OK, and then go back, activate a connection, click on it once to deactivate it, and then click on it a second time to activate it, and then go back and quit, and then reboot. So now we wait for this machine to boot up and we can test connectivity. So after all the machines have booted up, I want you to go into the master server and open terminal. And once in the terminal, one second, close. Now what we can do here is we can ping the other virtual machines to test connectivity. So from the slide, from here we can ping 56.10 and 56.20. So let's go back to the master server, 192.168.56.10, and we should expect a reply, yes. And then we can ping 192.168.56.20. Then we should have a reply from here as well. Looks like there's some problems with .20, so let's have a look. Go back to the dev server. Type in the password. And here let's type in IP-addr show. Okay, looks like the IP address is wrong. So nmtui, edit a connection, wired connection to. Yep, the IP address on this machine is wrong. So change it to 56.20. Everything else stays the same, and then we hit OK. Go back, activate, deactivate this, and reactivate the connection, and then quit. Let's double check the IP address one more time. It's the correct IP address this time, so let's go back to the master server and let's try to ping this again. Yep, we've got response. So this is how you can troubleshoot as well. Now from dev server, let's try and ping the master, 168.56.20, which is itself, and the master is 100. So we got a response from the master server. Let's try and ping the prod server as well. Prod is 10, so 56.10. We've got response from 56.10 as well. Now let's go to the prod server and try and ping both master and dev from here. So ping 192.168.56.100, which is the master, and 20, which is the dev server. So as you can see, we can now ping each server from the other server. With this way, we've established connectivity between all our virtual machines through the host-only network. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, in this lecture, we will set up local name resolution in our lab. Name resolution is a way of mapping an IP address to a friendly name. You do this on your mobiles when you store a contact. You can recall that contact by their name. You do not have to remember its phone number. Imagine how hard would it be if you had to remember all the phone numbers for all your friends. Similarly, it is very hard to remember all the IP addresses in a network environment. Therefore, we use name resolution to map friendly names to IP addresses. Now, local name resolution is a technique where you configure the host file on your system to map names to IP addresses. So let's head back to the Ansible master server to do this. Now in the master server, we can open up the terminal. And once inside the terminal, what I want you to do is type in sudo nano /etc/hosts. Now if you do not have nano installed, you can type in sudo apt install nano, and this will install nano on your system. You can use any other text editor like vi or vim, etc. It's really up to you. So sudo nano /etc/hosts and hit enter and type in the password for your user. Now in the host file under IPv4 settings, first let's change the localhost to master.testlab.com, and then we need to type in each of the IP addresses for the remote machines. So 56.10, and then type in the names. So 56.10 is the prod server. So let's type that in, prod.testlab.com, and then type in the next IP address for dev. And that should be it. We can now hit Ctrl X and save the file. And now let's try and ping the other servers through their friendly names rather than their IP addresses. So prod.testlab.com, and we've got a response. And let's try dev.testlab.com as well. And as you can see, this way we can set up local name resolution on our virtual machines. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Welcome back, guys. In this lecture, let's install the required software on Ansible Master Server and the remote machines. As you can see on the slide, we need to do the following. On the Ansible Master Server, we need to update the system and install Ansible. On the remote machines, we need to install OpenSSH server to enable SSH. We also need to allow port 22, which is the port used for SSH communication. And finally, we need to install Python on the remote machine. Now what I have done is, I have created two scripts to do these activities for us, and I have added a link to my GitLab page with this lecture. So once you click on the link, it should take you to my GitLab page. And on the GitLab page, you will see that there are two scripts, Ansible master.sh and remote machine.sh. The Ansible master.sh script should be run on the Ansible master server, and the remote machine.sh script should be run on the remote machines. Now let's have a look at both of these scripts. So on Ansible master.sh script, all I do is I add a repository on the system for Ansible, and then I update the system, and then I install Ansible, and lastly I check for the Ansible version that was installed. Now going back to the second script, the first thing I do is I install OpenSSH server, and once the OpenSSH server is installed, I allow SSH communication through the firewall on the system, and lastly we install Python. So again, Ansible master.sh script will need to be downloaded and run on the Ansible master server, and the remote machine.sh script will need to be downloaded and run on the remote machines. So let's go to the master server first. What I have done is I have downloaded the script in my downloads folder. And if you don't know how to download the script, all you've got to do is, once you've got the script open, you need to click on this cloud button to download the file, and it will start the download. So going back to the master server, if I do an ls under my downloads, you can see I've got the script already, and I have execute permissions on this script. But if you do not have execute permissions on your script, you can type in chmod u+x and then the script name, and this will give execute permissions for your user on this particular script. And now to run the script, all we need to do is type in sudo / and then the script name and hit enter. Now we need to hit enter one more time, and as you can see, it has started downloading files related to Ansible on the system. So let's go back to the remote machine And let's open up our dev environment first. Now on the dev environment, if we go to our downloads folder, dual LLS. Again, just to double check, we've got execute permissions. We can type in chmod u+x and then the script name, and then we need to type in sudo / script name to run the script, and they should start the install on this machine as well. Now we just need to wait for the install to finish. Now it looks like the script finished installing the required software, and as we've added the script to check Ansible version, you can see that Ansible version 2.76 was installed on the master server. Now let's head back to the dev machine to check the status. On the dev machine, it looks like it's still setting up Python, so we'll have to wait for a few more seconds. Looks like it finished installing Python as well on this. So what we can do is to check the status of OpenSSH server, we can try typing in systemctl status OpenSSH server and check the status of the SSH service. And looks like the SSH service is running. Now for Python, we can type in Python and we can see that Python version 2.715 was installed on the dev machine. Now you can duplicate these steps on prod machine to install this required software on the prod machine as well. With this, we have come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys. In the last lecture, we've set up Ansible on the central server and we've set up OpenSSH server on the remote machines. To validate SSH communication, we can type in SSH and then a username of a user on the remote machine. And as you can see, it has requested us for the password of that user. This is all well and good if a human is interacting with the remote machine, but in our case, we want Ansible, a software application, to interact with the remote machine. Now, using a password is not feasible when an application is interacting with the remote machine. Therefore, we need to set up what is called a passwordless SSH access. In a passwordless SSH, we utilize public private key encryption or asymmetric key encryption technology. In asymmetric key encryption, there are two keys, a private key and a public key. A private key is kept safe on the server and a public key is shared with the remote machines. Now these keys are generated using SSH keygen utility, and you can transfer the public key onto the remote machines using SSH copy ID command. So let's go to the master server and let's try this. So let's first do a clear, and now to generate the keys we can type in SSH keygen, hit enter, and we can use all defaults, and this will generate for us two keys using SHA 256 encryption. Now these keys are stored under your profile in .ssh directory. If you do an ls here, you can see there are three files. We are interested in these two. id_rsa is your private key and id_rsa.pub is your public key. Now the next step is to transfer the public key onto the remote machines. To do that, we need to type in ssh-copy-id and the username on the remote machine where we'll want to store our keys. So I want to store them in Labit, so Labit at prod.testlab.com and hit enter, and then it should ask me for the password of Labit. It says it has added some keys. It has actually added just one key, the other four are from my previous attempts. So now we can test this access. We can type in ssh labit add prod.testlab.com, and as you can see, it didn't ask us for a password this time. So you can exit out of this, and we can do the same thing for dev. Say yes, type in the password. It has added those keys, so let's SSH into dev now. And as you can see, we've set up passwordless SSH access between Ansible master and the remote machines. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, let's talk about the terminology used in Ansible in this lecture. A control node is any machine with Ansible installed on it. You can run commands and playbooks from any control node. You can also have multiple control nodes in an environment. However, you cannot use a Windows machine as a control node. A managed node is simply a machine that you manage with Ansible. It could be a network device or a server. Managed nodes are sometimes also called as hosts. We do not install Ansible on managed nodes. An inventory is a list of managed nodes. An inventory file is also sometimes called as a host file. Your inventory can specify information like IP addresses for each managed node. An inventory can also organize managed nodes. You can create and nest groups for easier scaling. A module is a unit of code that Ansible executes. Each module has a particular use case. It could be administrating users on a specific type of database, or it could be managing VLAN interfaces on a particular network device. You can invoke a single module with a task, or invoke several different modules in a playbook. Now, a task is a unit of action in Ansible. You can execute a single task once with an ad hoc command. A playbook is nothing but an ordered list of tasks. You save a playbook so you can run those tasks in that order repeatedly. Playbooks can also include variables as well as tasks. These playbooks are written in YAML and are easy to read, write, share, and understand. With this, we've come to the end of this lecture. Thank you for watching. Bye. Hey guys, let's talk about the configuration files in Ansible, and let's also run some ad hoc commands against remote machines using Ansible in this lecture. Now in Ansible, the configuration files are located under /etc/Ansible. And if I do an ls here, there are two files. Ansible.cfg contains all the configurations for your Ansible installation, and host file is your local inventory file and contains a list of all your managed nodes. We'll talk about roles in a later section. Now let's do a cat on ansible.cfg. Let's go all the way up. Now this file contains all the configuration values. So for example, it contains the location of your host file, your temp directories, what user it will use when it tries to become sudo, the polling interval. It also contains information like the path for your log file, path for your roles file, you can also turn off logging in this file. So this is the path for your log file, and it says logging is off by default, so if you want logging to be enabled, you need to turn it on. Also has the values for SSH timeout, etc. Now the next file I want to show you is the host file. So let's do a nano on the host file. So sudo nano hosts. Now this file contains a list of all your managed hosts. You can group the list of hosts using a group name inside square brackets. So here web servers is the name of the group, and all these values beneath web servers are the list of managed nodes that are part of the web servers groups. Now we've got two groups in our environment, a dev group and a prod group. Now it's also a good idea to have a group called all in case you need to run any commands against all the servers in your inventory. So under dev we need to type in dev.testlab.com, and then under prod you can type in prod.testlab.com, and then under all we need to type in both the names, so dev.testlab.com and prod.testlab.com. This way we can store the list of managed hosts in our inventory file. Now let's try and ping all these hosts using Ansible. To do that we need to run the ad hoc command, so I'll type in Ansible -m, and then the command I want to use is ping, and I want to ping all the servers. So I'll type in Ansible -m ping all, and looks like we've got success in pinging those servers. Now next we can try and let's try and run a command on those servers. So we can type in Ansible -m. Let's use the shell module and -a, and let's give the command free -m, and this will tell us the free memory, and I want to run it against, let's first run it against all the servers. And as you can see, what it did was it used the shell module for Ansible, and then it logged into each server, ran free -m, and it gave us our results here. To run it against a particular group, we just need to change from all to that group's name. So it has returned the list of servers from that group, and because we just had one, it gave us results from only one server. We can also run it against a single server like this. So dev.testlab.com, and in this way Ansible will log into dev.testlab.com, run free -m, and give us the results on our screen. So these are the results. In this way you can run ad hoc commands using the console. With this we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Hey guys, in this lecture I will show you how you can look up Ansible documentation online, and also we will write our first playbook. Now Ansible documentation is available to us in https://docs.ansible.com. When you get to that page, you'll get to see all the sections available for you. I suggest you start with getting started. Now getting started page has some good stuff like how you can run your first commands. So for example, how you can edit the host file, and how you can run commands such as ping command. On the left hand side you have all the sections and subsections available for you. For example, you have a section for working with modules, how you can work with playbooks, what are variables, how you can use ad hoc tools. You can also search for anything. So for example, if I want to search for shell module, I can type in shell module and hit enter, and then I can look for shell module from among the search results. So let's click on shell, and the format of the documentation is pretty simple. So you've got an index for the page here, then you have a synopsis of that particular module, then the parameters you need to pass or you can pass to that module. For example, if you want to create a file using shell module, you use creates, and then some examples of that particular module. And lastly, what return values you can get from that module. Now let's head back to the master server to create our first playbook. I'm going to use Visual Studio Code as my IDE for this course. You can go to Ubuntu software, search for Visual Studio Code, and then install this software. Now I have a folder Ansible inside my documents where I'm going to store all my scripts. So I can select Ansible, can click on new file. I can name the file basic.yaml, and once it opens up the file for me, because this is a YAML file, I can start it with 3 dashes and then I can hit enter. Then the first thing I need to specify for this YAML playbook is what hosts I'm going to run this playbook against. So you can do that by typing in dash and then space and then hosts. Then I need to specify the hosts. I'm going to run this against all hosts. What this all means is the group inside my host file. So if I go to my terminal and if I do a cat on the host file, we have 3 groups: dev, prod, all. We need to specify one of these. So I can either specify dev or prod or all. I'm going to run this playbook against all, which is why I've specified all. I could easily have said dev or prod here, but I want to run this against all. Now spaces are very important in YAML, so just be mindful of that. The next thing I want to do is I want to start the list of the tasks that I want to include in this YAML. So I'm going to type in tasks, and then under tasks I'm going to give the name of the first task that I want to run. I can type in name for that. So I'm going to type in this is a basic connectivity test. And the task to test connectivity is ping. And then I can end my YAML with 3 dots. So all I need to do is save this file now. So first I've entered the name of the host group that I want to run the playbook against. I want to run it against all. And then I've started my list of tasks. I've given the name of my first task, and the task I'm going to run is ping. Now to get some documentation about ping, we can go into the Ansible documentation and we can type in ping, and from the search results we can click on ping, and the synopsis is that it is a trivial test module and will always return pong on successful contact. The only parameter it has is data. It says data to return for the ping return value, and some examples. So this is how we utilize ping. Now heading back to the lab system. To run this command, or rather this playbook, we need to go back to our terminal, and on the terminal we need to type in the command Ansible Playbook and then the location of the playbook. I have saved the playbook inside my documents folder, so I will type in documents and then inside Ansible folder, and then the name of the playbook is basic.yaml, and I can just hit enter. And if I put in the syntax correctly, it should start running the playbook. So play all, this is the group I specified in the host file here, and then it started running the task, and this is the name of the task we gave, and this is the result of that task. Now this is how you can write your playbooks and you can run them. The next thing I want to show you is how you can add comments in your playbooks. It's very simple. You can just type in a hash, and anything that follows the hash is a comment, like this. Comments will not be executed when the playbook is run. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, version control systems are a category of software tools that help a software team manage changes to source code over time. If a mistake is made, developers can turn back the clock and compare earlier versions of the code to help fix the mistake while minimizing disruption to all team members. By far, the most widely used modern version control system in the world today is Git. I have uploaded all the playbooks and other files used during this course in a public repository on GitLab. The URL is gitlab.com/labit/ansible, and I have also attached this URL with this lecture. So in this lecture, I will show you how you can download all these files using Git. Now the first thing we'll need to do is we need to go to our terminal and first install Git. So to install Git, we need to type in sudo apt install and then Git, and -y to just accept all the prompts, and this should start the install procedure. Now once Git is installed, we can go back to the web page for GitLab and go up, and here on the clone button, when you click on it, you will see there are two options, clone with SSH and clone with HTTPS. We are going to use the HTTPS method. So just click on this copy URL to clipboard icon, and let's go back to our terminal. Now we will be cloning these inside the documents folder on my Linux machine. So I will go into the documents folder first and can click on ls, and there's nothing there. Now to clone the repository is very easy. You can just type in git clone and then paste the URL that we got from the clone button on the web page, and then you can just hit enter, and this should start the clone. It's pretty quick, so let's do an ls here. So you see there's a directory named Ansible here, so I can just go inside the directory and do an ls again. So I've got the readme file and other scripts, and let's go into simple playbooks. And then you can see all the playbooks here. In this manner, you can download all the course playbooks and scripts using Git. I would suggest that you go online and read more about Git, because when you're working with Ansible, there's a very high chance that you'll also be working with Git. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, let's have a look at how you can manage your inventory in Ansible in a bit more detail in this section. If you remember from previous sections of this course, an inventory is a list of hosts that you manage using Ansible. The default inventory file is located in /etc/Ansible. So let's head back to the Ansible master system and let's type in sudo nano /etc/Ansible/hosts to open up the host file. Now this file has some nice explanation on how you can configure your inventory file. You can also go to the link I have provided with this lecture, and this link will take you to the official Ansible documentation. Now if you remember, we added our host in 3 groups, dev, prod and all. Now if we had more than one server in each group and those servers had a pattern in their host names. So let's say the server names are like this: dev1, dev2, dev3, dev4, etc. So the pattern here is 1, 2, 3, 4. We could use this pattern and add a range instead of adding each server as a separate entity. So we could type in dev and then square brackets and then 1 to 4 to specify all the 4 servers in the dev group. Now this pattern also takes alphabets, and you can also use colon to specify the pattern. These are all valid entries. Now let's say if you have a particular host where you want to run the Ansible scripts as a non-default user. So let's say by default you're running Ansible as user A on each remote machine, but for a particular host, let's say on the prod server, you want to run Ansible as, let's say, John Doe. Now to do that, you can just go to the host where you want to specify a user, type a space, and then after the space type in Ansible underscore user is equal to, and then the username. So let's say John Doe is the username. Now next, your company might be running SSH over a non-default port, which means any port other than port 22. In that scenario, to specify a non-default port for Ansible, you will go to the host where you want to specify the non-default port, type in a colon, and then type in the new port. And this way you can specify a non-default port for SSH communication. Now next, let's say you have a scenario where let's say on the dev box you have Ansible master running on the dev server, and also there's another application installed on the dev server which you want to manage through Ansible. Now in this scenario, Ansible will need to connect to the local host on the server in order to run those automation scripts. So you can utilize Ansible connection parameter in order to achieve that. So we can type in Ansible connection after the host name and then is equal to, and then local to specify that Ansible will need to be run locally on this machine. Now the other value you can give to connection local is SSH. Now next, you can also assign some host variables to each host in the inventory file. Now an example of why you would want to use host variables will be to set up things like application port numbers for a particular port. Now let's say you have Apache running on port 80 on one host and running on port 8080 on the other host. So let's say on the dev environment you have got Apache running on port 80, and in the prod server Apache is running on 8080. We can specify a variable. So let's call the variable http underscore port, and we can give it a value 80 for dev, and we can specify the same variable for the prod.testlog.com server as well, and for this server let's specify the value 8080. So this way you can assign host variables to each host in the inventory file. Now you might have a scenario where you want to assign variables to a group instead of a specific host. In order to do that, you can go to a new line, type in square brackets, and then inside square brackets first you need to specify the group name and then colon and then vars, and this will tell Ansible that these are the variables that need to be assigned to a particular group, and in our case this group is dev. And you can assign the variable after this. So let's say we want to assign a proxy server to the dev environment, so proxy underscore server is equal to dev proxy .testlab.com. Now we can do the same thing for the prod environment as well. So prod vars Now this way you can assign group variables. Now next, let's talk about supergroups. Supergroups contain multiple groups. So let's say you have a dev environment, a test environment, a prod and a staging environment. So dev, test, staging and prod, and the server in test environment is test1.testlab.com, and in the staging environment the server name is staging.testlab.com. Now let's say you want to create two supergroups, one supergroup with dev and test and one supergroup with staging and prod. So to create those supergroups which have multiple groups in them, you can type in square brackets and then the supergroup name. So let's call them lower environment and colon, and then we need to specify the suffix children, and then we need to specify the children of the lower environment supergroup, and the children are dev and test. Now let's specify the second supergroup, and let's call this upper environment, and we need to specify children suffix, and the upper environments are staging and prod. Now the main benefit of using supergroups is we can assign variables to these supergroups. So let's say both dev and test, which are the lower environments, have a common FTP server, and the upper environments have a common FTP server. So because we have supergroups, we can assign the FTP server to the supergroup, and this will in turn assign them to each group and then to each host in those groups. So let's do that. So to assign variables to a supergroup, we can first specify the supergroup name inside square brackets, so lower env, and then we can specify a colon and then vars, and here we can specify the variable, so ftp underscore server, and then is equal to, and let's give it the FTP server name IP address, and then for the upper environment we can specify variables as well, so FTP underscore server. So in this way you can create supergroups and assign variables to those supergroups. Now by default there are two groups that are always there in an inventory file. These are the group all and another group called ungrouped. Now you do not need to assign any host to these groups because the assignments are implicit, and all contains every host in your inventory file, and ungrouped contains all hosts that don't have any other group assigned aside from all. So you might have a situation where you have an all group and you have a server myserver.testlab.com, and this server is not assigned to any other group apart from all. So this server implicitly will be assigned to ungrouped. Every host will always belong to at least two groups. Therefore, because of this, myserver.testlab.com will be assigned to all and ungrouped. Now, next, you do not need to store your inventory in the default location, which is /etc/ansible. So let's head out of our host file and let me show you how you can run your playbooks with the inventory file from a non-default location. But before that, let me show you how you will run your playbook when you have a default inventory file. In that case, you will just type in Ansible Playbook and then you'll just type in the location of the inventory file. So let's say documents and then Ansible and then simple playbooks, and I think I've got a playbook called basic.yaml in here. If I run that, this will use the default inventory file to start the playbook. And as you can see, it has started this playbook basic.yaml with the default inventory file. So let's Control C and let's clear this. Now let's then copy our inventory file into a different folder. So copy /etc /ansible /hosts, and let's copy it to /downloads. Now let's go into downloads. So you got the host file here, which is a non-default location. Now in order to run our host file from a non-default location, we need to type in Ansible Playbook, then -i to specify the location of inventory file, and then we can type in downloads /hosts, and then we can specify the location of our playbook. So in the previous command, let's just type in -i /hosts, and this will start the playbook from inventory file in a non-default location. So this way you can use a non-default location for your inventory file. With this, we've come to the end of this long lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, in this lecture, let's understand how you can specify the host variables in separate files. This is the recommended method to store host variables in Ansible. You'll need to create a directory structure like this. So you'll have a top level directory, and then inside that top level directory, you'll have your hosts.yaml file, and then you'll also have a subdirectory called host_vars. And inside the host_vars subdirectory, you'll have a single file for each of the hosts that you want to store variables for. Now let's head back to the lab system. Here, inside my documents folder, there's a directory called Ansible. If I do an ls here, what I've done is I've created two subdirectories, a subdirectory called inventory and a subdirectory called simple playbooks. Inventory will contain all my inventory related files and subdirectories. So the hosts.yaml file, the host_vars subdirectory, and simple playbook will contain my playbooks. Now if I open my Visual Studio Code, if I open the inventory folder, you can see that inside inventory I have hosts.yaml file, and this file has a list of all my hosts, and inside the subdirectory host_vars I've got the two files for two hosts that I have in my environment. Under dev.testlab.com.yaml I have two variables, and in prod.testlab.com.yaml I've got two variables. Now in simple playbooks, I have a playbook command module which will utilize command module to create a file inside one of the remote machines, and it utilizes variables. So let's go through this playbook. First, we assign host, and we are telling it that we'll be assigning dev environment for this playbook. So this playbook will be run against the dev environment. Then we specify a task, then we name the task, and then under command we give it the command, and the command is touch to create a file, and then we've specified the variable test underscore file. Now if you go to dev.testlab.com.yaml, you see that there's a variable called test underscore file, and the value for that variable is readme underscore dev.txt. So this is the name of the file that will be created on the remote machine dev.testlab.com. So going back to the command module, next we provide some arguments. We say before you create this file or you run this command, change directory to test underscore dir, and test underscore dir variable is specified in host underscore vars slash dev.testlab.com.yaml, and the value for test underscore dir is the documents folder on the remote machine. And then the creates argument specifies that if the file already exists, do not run this command. So let's run this. So let's go to terminal and type in Ansible Playbooks, and then specify the inventory file, and the inventory file is under documents slash Ansible inventory, and then the name is host.yaml, and then we can specify the playbook file. So downloads Ansible simple playbooks, let me double check the name of the directory. So simple underscore playbook inside Ansible. Oops, so I started off with the wrong path. So document Ansible simple underscore playbooks, and the name of the file is command module.yaml. Command module.yaml, and we can run this command now. And looks like the syntax was correct, and it has started running our playbook, and looks like it has finished running our playbook. And you can see that the playbook was run okay, and it changed one file. So let's head to the dev system, and in the dev system, if we have a look at our inventory, so there should be a readme underscore dev file in documents folder. So let's go to documents, and then do an ls, and as you can see, there's a file called readme underscore dev.txt. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, let's talk about group variables in this lecture. Group variables are used when you want to set variables at group level. You will need to create a directory called group underscore vars at the same level as your host file. Basically, you'll have a structure like the one I have on my screen. You'll have a top level directory, and then your hosts.yaml file inside that top level directory, and then a subdirectory called group underscore vars at the same level as hosts underscore YAML, and then 3 files inside group underscore vars to specify the 3 groups that we have in the host file. Now let's head back to the master system. So here inside my documents folder, I have a directory called Ansible, and inside Ansible I have a subdirectory called inventory and simple playbooks. In the inventory subdirectory, I have all my inventory related files and directories. So there's a host.yaml file, and at the same level I have another subdirectory called group_vars. If I go inside group_vars, if I do an ls, I have three files: all.yaml, dev.yaml and prod.yaml. Now inside dev.yaml, I have a variable test_dir, which refers to the downloads folder on the remote machine. In prod, I have a variable called test_dir, which refers to the documents folder. So dev refers to downloads and prod refers to documents. And all.yaml has a variable called test_file, which contains the name of the file. Now again, I'll be running the same playbook, command module.yaml, and what it does is it creates a file which has the name that comes from variable test_file, and it changes directory first, so it goes into test_dir. So what should happen is, on the dev system, it should actually go to downloads folder and then create a file readme.txt, and then it should go to the documents folder on the prod system, and there it should create a file called readme.txt. So let's go to the terminal and run the same command. But I forgot one thing first. So first, just for the sake of not having any conflicts, let's first go to the dev host file and then comment out the variable values, because I don't want any conflicts when I'm running the command, and we've got similar variable names because we haven't changed anything in the playbook. So this way there are no variables assigned in the host file. So host_vars, on the host file there are no variables assigned, so 100% the playbook should take the group_vars variables, and we'll be running the playbook against the variables in dev group. So let's go to the Ansible Playbook command that we used. So Control R, and we can search for the same command. And the file is still the same file and the playbook is still the same, so we can just simply run this. It looks like the syntax was correct, and you can see that the playbook was run successfully. So let's head back to the dev system to verify that the file readme.txt was created. Now first let's go to the master system and on Visual Studio and check what was the directory on dev. So downloads. So let's go to the downloads folder first, to an ls, and as you can see that readme.txt was created on the downloads folder inside the dev system, which means, going back to the master system, our playbook utilized test_dir variable from dev.yaml file inside group_vars subdirectory, and it used test_file variable from all.yaml inside group_vars. So this way you can utilize group variables inside your playbooks. With this, we've come to the end of this lecture. Thank you for watching. Bye. Hey guys, in the last few lectures we spoke about host and group variables. By default, variables are merged or flattened to the specific host before a play is run. This keeps Ansible focused on the host and task. So groups don't really survive outside of inventory and host matching. Ansible overrides variables including the ones defined for a group or a host. This setting is controlled by #behavior inside your ansible.config. So the default value for #behavior setting is replace, which means whenever it finds an overlap, it replaces the values based on an order of precedence. You can also set this to merge. Now the order of precedence that Ansible uses is first is all group. So if all group has a variable that has an overlap with a variable in parent group, the variable from all group would win and its value will replace the value of variable from parent group. Similarly, a variable from parent group will win over a variable from child group, and a variable from child group will win over a variable from host group. Now, another scenario is when you have two groups that are at a similar level. So going back to our master system, and in the host file, you can see I have two groups, dev1 and dev2, at the same level. Now if I go into dev1.yaml, which is the group variable file, there is a variable called test_dir, which is a value of /etc. And on dev2.yaml also, there is a variable called test_dir with a value of downloads. Now in this scenario, if dev2 gets loaded last, then the variable of dev2 that matches dev1, in our case test_dir, will override the variable of dev1. So test_dir for dev2 will override the value of test_dir for dev1, which means when we use test_dir in our playbooks, it will utilize downloads as the value. Now you can control this behavior starting version 2.4 by using Ansible_group_priority. With this, you can define a priority with each variable or a group. The default priority is 1. So if you don't set any priorities on dev1, but you set the priority on dev2 to 10, you will make sure that the variables of dev2 will always win in case of an overlap. Now this is how Ansible handles overlap of variables. This is pretty important information, so always keep this in mind when you are setting up your variables. With this, we've come to the end of this lecture. Thank you for watching, and I will see you in the next one. Bye. Hey guys, in this lecture, I want to show you various parameters that can be used to control how Ansible interacts with managed nodes. I have attached a link to the Ansible documentation, which has a complete list of inventory parameters. First, Ansible_connection specifies connection type to the host. This can be the name of any of Ansible's connection plugins. SSH protocol types are Smart, SSH, or Paramico. The default is Smart, and Paramico is the Python implementation of SSH protocol. There are some general parameters as well. Ansible_host allows you to specify the name of the host to connect to. Ansible_port allows you to specify a non-default SSH port. Ansible_user allows you to specify the username of the user that you want to run the Ansible scripts as, if you do not want to use a default username. Some of the SSH parameters are Ansible_SSH_pass, which allows you to specify the SSH password. Ansible SSH private key file allows you to provide a private key file. Now there are some privilege escalation methods as well. Privilege escalation is a method used to gain extra privileges on the remote system. Ansible_become is equivalent of sudo or su and allows for force privilege escalation. Ansible become method allows you to specify the become method that will be used. Ansible become user will allow you to set the user you want to become through privilege escalation. Ansible become pass allows you to specify the privilege escalation password. Now, as stated in the previous sections, Ansible executes playbooks over SSH, but it is not limited to this connection type. So you can specify connection types like local, and this connector can be used to deploy the playbook on the Ansible controller machine itself. You can also specify Docker, and Docker connector can deploy playbooks directly into Docker containers using local Docker clients. You can specify containers, the parameters like Ansible_host, user, become, and some extra arguments by typing in Ansible_docker_extra args. With this, we've come to the end of this lecture. I will recommend you to go through the link provided with this lecture and go through the list of inventory parameters. Thank you for watching. I will see you in the next one. Bye. Hey guys, playbooks are Ansible's configuration, deployment, and orchestration language. At a basic level, playbooks can be used to manage configurations of and deployments to remote machines. Playbooks are written in YAML and consist of one or more plays. The goal of a play is to map a group of hosts to some well-defined roles which are represented by tasks. Now, these tasks are nothing but a call to an Ansible module. Ansible uses modules to accomplish most of its tasks. A module can do things like installing softwares, copying files, etc. etc. Now let's head back to our lab system. Now in this lecture, we will write our playbook and we will utilize a module called shell. Here on the screen, I have the help page for shell module. Now as you can see, the shell module takes a command followed by a list of space limited arguments, and it executes those commands on the shell on remote machines. For Windows targets, you will need to utilize win_shell module. So this shell module works on Linux machines. Now here are some parameters that we can utilize when we are using the shell module. Chdir changes into the directory before running a command. So for example, if you want to create a file in a particular directory, you will utilize chdir to go into that directory first before you run the command. Creates will only run the command if the file does not exist. If the file already exists on the remote system, this step will not be run. Executable allows you to change the shell used to execute the command. So for example, you're running your script in bin bash, but for some reason you want to run a particular task in another shell, you will utilize executable. Removes will not run the step if the file does not exist. So it's opposite to creates. Now stdin or standard in will set the standard input of the command directly to the specified value, and warning will allow you to choose whether to enable task level warnings or not. If we go further down on the help page, you will see some notes related to the module, and then you will see some examples. For example, this is how you will utilize shell module. This is how you utilize shell module with some arguments. This is the use of chdir and creates. This is how you can run expect to wait for a successful Pixie boot. And this is how you can disable warnings. So let's create our first playbook using shell module. Now I will need to go into my Ansible folder and then create a file. I want to call this file shell module example.yaml. I could also type in YAML it doesn't matter. Once I've created the file, I will start with 3 dashes, and then after the 3 dashes I will hit enter, and then the first thing I need to specify is the hosts that this playbook will run against. So hosts, and then specify the host group. I want to run this again dev. Now at the same level as hosts, I need to specify tasks to tell the playbook that I'm going to write some tasks. Under task, at the next level, so a space and then dash and then a space. I will type in name, and the name I'm going to give is create a simple file using shell module. Now at the same level as name, I'm going to call shell module, and then I need to specify the command that shell module will run. So let's do touch mytest file.txt. Now what we want to do is we want to create this file under a specific directory. So let's do args to specify some parameters. Now at the next level from args, which means after typing in space, I will type in chdir /home /user, so Labit, and then downloads under the user, and creates, and I will do a creates on my test file .txt. So basically what our playbook will do is it will create a file called mytestfile.txt in directory home Labit downloads, and it will run a check before it tries to run the command that if the file mytestfile.txt exists on the remote machine or not. If the file already exists, it will not create the file again. Now we can finish it up by typing in 3 dots. Now let's save the playbook and let's try and run it. So Ansible Playbook, and then I need to specify the path of my playbook. So documents, Ansible, and then the name of the playbook, so shell module example.yaml, and I can hit enter. Now it has started to run the playbook, which means our playbook does not have any syntax errors. One thing you might want to note when you're writing your playbooks is these spaces. You have to be very accurate with these spaces. If we move a space here or there and the line is not at the correct level where it should be, you will have an error. Now we've got some output, so let's increase the terminal size. So we ran the command to run our particular playbook. Now play dev is telling us which set of hosts the play is running against. I'll tell you about gathering facts later in this lecture, or rather in this course. And then it says OK, and then it gives us the host name against which it is going to run, so dev.testlab.com. Then task, and this is the name we gave to the task, create a simple file using shell module. And then it gives us some warning that you should not use touch, we should actually use something else, but it's okay. And then changed dev.testlog.com means that our playbook was successfully run, and as a result the remote machine was changed. And then it gives us a play recap that the play was run against this particular host. There were two OKs. It changed something. There were no unreachables, no fails. Now, if we go to our remote machine and if we do an ls here, you can see that we have a file called mytestfile.txt here. Now, because we used creates in our task, if I was to run this playbook again, my expectation is that this task will not be run because the file already exists. So if I hit an up arrow and hit enter, let's see what happens. Now in this one we have play and then dev, the set of hosts. Then the task create a simple file using shell module, and in the play recap we have changed is equal to 0. So here we had changed is equal to 1, which means it created the file mytest file. Here when we ran it the second time we have changed is equal to 0, and that is because it did not create the file this time, it skipped the task. With this we have come to the end of this lecture. I hope you've enjoyed it. I will see you in the next one. Bye. Hey guys, in this lecture I want to tell you about a term called idempotency. Idempotency is the property of certain operations that can be applied multiple times without changing the result beyond the initial application. In Ansible terms, it means if you run a playbook multiple times, you will always achieve the same state. You will not have two different states by running the same playbook. This is necessary to ensure you have a consistent state in your environment. There is another term called configuration drift, where servers in an infrastructure become more and more different as the time goes on. Now we need to combat configuration drift, and this is why we use tools like Ansible. So we can run playbooks or write playbooks which when run multiple times will achieve the same state always. Now modules should be idempotent. That is, running a module multiple times in sequence should have the same effect as running it just once. One way to achieve idempotency is to have a module check whether its desired final state has already been achieved or not, and if that state has been achieved, to exit without performing any actions. Now, in the last lecture, when we used the creates flag, we were actually making this playbook and the module idempotent, because since we used the creates flag, even though we ran the same playbook twice, we actually did not change the state of the system the second time we ran it, because we'd already achieved the final state in the first run of the playbook. So whenever you're writing playbooks, just make sure that you have the principle of idempotency in mind, so that your remote systems are always in the desired state and you minimize configuration drift. With this, I've come to the end of this short lecture. Thank you for watching. I will see you in the next one. Bye. Hey guys, some tasks require higher privileges for execution, such as installing softwares on the remote machine, restarting services, etc. Ansible allows you to become another user, which is different from the user that is logged into the remote machine, using existing privilege escalation techniques such as sudo, su, etc. You can use become and set this flag as yes to activate privilege escalation. If you just use become yes, you can execute playbook on the remote machine as root user. Become underscore user allows you to execute playbook as a particular user. For example, let's say you've got a user set up on the remote machine which has the desired privileges that you need to use to execute your playbooks. You can use become_user to set yourself as that particular user on the remote machine before you execute your playbook. Become_method, which can be set at play or task level, overrides the default method that you've set in the Ansible configuration file, such as sudo, su, etc. etc. Become_flag permits the use of specific flags for the task or role. A common use is to change the user to nobody when the shell is set to no login. Now, let's head back to our lab system. Now, on the lab system, let's try and create a playbook that installs Apache on the remote machine. Now, we need to go into our Ansible folder, click on the new file icon, and name the playbook install_apache.yaml. And inside the playbook, let's start the playbook by using 3 dashes and then a single dash and space to specify the hosts. As usual, we're going to run it against dev. Then at the same level, we will specify become space yes to allow us to use privilege escalation. And then we can specify tasks and then a space to go to the next level from tasks and name. And under name, we will simply say this will install Apache on remote. I need to add a space between dash and name. Now at the same level as name, I need to specify the module I'm going to use. Since our remote is Ubuntu, we can specify apt because that is the package manager for Ubuntu. And now at the next level from apt, we need to specify some parameters. I've got the help page for Ubuntu here. So if we go all the way up, it says apt manages apt packages for Debian and Ubuntu. There are some requirements and parameters. We are going to use the parameter name to specify a list of package names that we are going to install. In our case, it will be Apache 2. We can specify a name like this, as in just the name of the package, or like this, as in the name and the version of the package you need to install. We can also use wildcards like this. Now next, we are also going to use state, and the choices for states are absent to make sure that particular package is absent from the remote machine. Build dep will ensure the package build dependencies are installed as well. Latest will ensure the latest and greatest version of the package is installed on the remote machine. Present works with name. So if you specify present and specify a version in the name parameter, Ansible will ensure that that particular version is present on the remote machine. If that version is already installed, this task will not be run. But if it's not installed, or it is at a lower level or a higher level, it will either bring the version up or down to the particular version you've specified using the name parameter. Update cache will perform the equivalent of apt-get update on the remote machine. Upgrade is used to upgrade the remote machine, and the options are dist, which performs a apt-get distribution upgrade, full, which performs a apt full upgrade, yes or save, which performs a safe upgrade. Now let's head back to our playbook, and here the first thing we need to do is specify a name. So name of the package is equal to Apache 2 8_cache, yes, and state we want latest. Now before we run this playbook, let's save this. Before we run this playbook on the remote machine, we need to change some configurations on the remote machine as well. This is a one-time only configuration task. You can automate this task as well, but it's probably a bit complicated at this stage. However, I can promise you that during this course, towards the end, I will show you how you can automate this task as well. So we can go into dev, and in the dev system, let's first do a sudo -i to switch into root, and here let's run nano/etc/sudoers to open the sudoers file. Now this file configures the behavior of sudoers on the system. Now here, if you see, under user privilege specification, you've got root user as all. What we need to do here is that we need to specify sudo, which means allow members of group sudo to execute any command. Under here, what we need to do is after all, we need to specify no password to allow us to be able to run sudo commands without password. So we need to go here and then passwd space all, and let's do the same thing for root as well. And then Control X. No. What I want to do is I want to back up this file first. /etc _pkp. This is always a good idea. And now I can go into sudoers and under root and the same thing under sudo as well. Now we can save this. Now let's head back to the remote system or our Ansible controller, and here we type in Ansible Playbook. And now let's run this playbook. So now if you can see, we've got task which says the name that we've specified and says it changed the remote machine. You can see OK is equal to 2 and change it is equal to 1, which means we were able to successfully install Apache 2 package on the remote machine. Now if we go to the dev system and if we do cd/var/www/html, we can see that the directory exists and there's a default index.html on this directory, which means Apache was actually installed on this machine. You can also do a cat and it shows the default Apache index file. Now with this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Hey guys, in this lecture, we're going to do a small project. What we're going to do is we're going to install LAMP stack using our knowledge of Ansible and Playbooks. What you will need to do is you will need to install the following packages: Apache 2, PHP, PHP MySQL, and MySQL Server. Then you will need to deploy a new index.html file, which I have attached with this lecture. So you will need to deploy this file onto the remote machine, and then you will need to start Apache 2 and MySQL Server service using handlers. Now what I want you to do is I want you to pause this video now and give it a go yourself. If you're not able to do it, then I will show you how to do it. But first, give it a go yourself. I will pause this video, and once you've got an answer, then come back and compare your answer against mine. So pause the video now. Okay, welcome back. If you haven't tried it yourself, I would still ask you to go ahead and try it. But if you had tried it and either you failed or you want to compare your answer against mine, let's head back to the Ansible controller. So inside my Ansible folder, I've got the index.html file that is attached to this lecture as well, which is a basic HTML file which we will deploy on the remote machine. And I also have a playbook called install_lamp.yaml. Inside this playbook, I first specified the environment I'm going to run this playbook against, which is dev. Then, because I will be installing packages and restarting services, I've used become yes to gain higher level privileges. Then the first task is to install LAMP packages on the remote machine. I've used apt module, and using the package parameter, I've supplied it a list of packages that I want to install on the remote machine. State is latest to install the latest versions of all these packages. Then I've called 3 handlers using the notify mechanism. The first one is start Apache, the second one is start MySQL Server, and the third is deploy index.html. After that, I've specified the tasks for all these 3 handlers. The first one is to start Apache. I've used the service module to start the Apache service. So I've given it name Apache 2, state started, and enabled yes. Enabled yes allows me to make sure that the services are available automatically when you restart the server. So it adds this into the boot list of your server. Then I've also done the same thing for MySQL Server. And lastly, I've got the task to copy the index.html file onto the remote server inside var/www/index.html location. Now let's run this file. So Ansible Playbook, the path of the file, and install_lamp.yml. Let's run this. Now, as you can see, our playbook was run successfully, and we've got 5 OKs and 2 changed. Now to verify, let's head back to the dev system. And on the dev system, let's first check for the status of the MySQL service. says active and running. And now to check Apache, what we can do is we can open up our browser, and what we're going to do is we're going to open up the browser for localhost, which will send it to the Apache server running on the local host, and that Apache server will display our index.html file that we've deployed on this box. So let's do it. So click on Firefox. Now on our browser window we can type in localhost to open up our index.html that we deployed. So we type in localhost and all we need to do is hit enter. Now as you can see, it has picked up the new index.html file and we've got the relevant text on the screen. So this is how you can deploy LAMP stack using Ansible. With this, we've come to the end of this lecture. Thank you for watching. I will see you in the next one. Hey guys, a better way of organizing your playbooks is to use roles. Roles are a way of automatically loading certain variable files, tasks, and handlers based on a known file structure. Grouping content by roles also allows easy sharing of roles with the other users. So for example, if we were to install our LAMP stack using roles, we will create one role for Apache, one role for MySQL Server, and one role for PHP. This allows us to reuse these roles, so in case where we only want to install Apache on a set of servers, we can only call Apache, and in the case where we want to install all three, we can call all three roles. Now let's head over to our Ansible controller system. Now the first thing we need to do is, I want you guys to check if you've got tree command installed. Tree allows you to see the directories and its subdirectories in a tree-like structure. So if I was to show you my documents, this is the view that tree command will give you. To install tree is very easy. You just need to type in sudo apt install tree and hit enter, and when it prompts you need to type in your password. Now since I had tree already installed, it didn't upgrade. Now with tree installed, we can now go ahead and start creating our roles. Roles are created using the Ansible Galaxy command. So if I type in Ansible Galaxy and if I do a -H to open up the help menu for Ansible Galaxy, you can first see the usage of Ansible Galaxy. So we need to type in Ansible Galaxy and then one of these options. So delete, import, info, initialize, install, list, login, remove, search, setup. Then help, which is if you need help, and then some options. And the options are -C to ignore certificates, -S to set up API server destination, and -V for verbose, and -- version. We will use init to initialize our role. So let's clear this. First we need to make sure we're in the Ansible directory. Now inside Ansible directory, we've got all our playbooks. What I would do is I would create a new directory called roles, and then inside roles I will create our first role. So I will type in Ansible Galaxy init and then Apache, because we will install Apache using these roles. Now if I do an ls inside roles, you can see I've got a directory called Apache. Let's do a tree on that directory. Now as you can see, it has created a directory structure with some subdirectories and some files within those subdirectories. Now going back to the slide, first we have the defaults subdirectory, which holds all the default variables for this particular role. Then you have the files subdirectory, which will contain the files which can be deployed via this role. For example, the index.html file for an Apache server. Handlers will contain handlers which may be used by this role or even anywhere outside this role as well. Meta contains some meta information for this role, for example, author name, platforms which are supported, etc. Tasks contain the main list of tasks to be executed by this role. Then we have templates, which will contain templates in Jinja 2 format which can be deployed through this role. And lastly, we have the vars subdirectory, which contains other variables for this role. The variables defined here takes precedence over the variables that you define in the defaults folder. So whenever you are setting up a role, just be careful where you're defining your variables. If you got a variable that has the same name and it's present in defaults and vars, the one in vars will take precedence. Now going back to the Ansible controller. So in this lecture, I'm going to show you how to create a role for Apache server. Now the tasks for installation of Apache server can be broken down into 3 steps. The first step is to install the Apache server. The second step is to configure the Apache server. Now for this step, we will send a custom apache2.config file over to the Apache server. We will also copy an index.html file over to the remote machine as well as part of this step. Third, we will need to start the Apache server. Now let's get started. So first we need to go into the tasks subdirectory, because going back to the slide, the tasks directory contains the main list of tasks to be executed by this role. So in the tasks subdirectory, we will use Visual Studio Code rather than terminal to do this. So I'll just minimize my terminal to this much, and then I will hit refresh here to refresh my workspace. Now you can see I've got roles and I've got Apache inside roles. Now inside tasks, I've got a main.yaml. Now because we had broken down the installation steps into 3 distinct steps, we're going to create 3 files. The first file is install.yaml, or rather we will use YAML. It doesn't really matter in Linux, but since in roles we've got the extension YAML, just for keeping everything same, I'm going to name the extension YAML while using roles. The next file I'm going to create is configure.yml, and the last file is services.yml. Now under install.yml, we will write the tasks needed to install Apache server. So let's start with 3 dashes and then the name of this task, install Apache server. Now here I'm going to call apt module, and then name of the service or the package we need to install. The package will be called Apache 2, and the state of that package would be latest, and that's it for this one. Now under configure.yaml, I'm going to write 2 tasks. One would be to configure the web server, which means we will be sending over a custom Apache config file onto the web server, and second we will deploy our index.html. So 3 dashes minus name, deploy custom apache2.conf file, and we will use the copy module, and we will type in src equals the name of our custom Apache file. I have actually attached this file with this lecture, and I've downloaded this file on my system as well. In my downloads folder, looks like I had to download it again. So here's the file in my downloads folder. I can just copy this file into my Ansible folder and then roles, then Apache, and inside the files folder, and I will also need to copy the index.html file. And now once this is done, let's head back to our Visual Studio Code and let's do a refresh. Now you can see that our file apache2.conf is there, and I put a line at the top saying file was customized by me for demonstration purposes, and this is our index new.html, and rather than using tasks I will just say using roles. And let's save everything. So going back to configure.yaml, so our source is apache2.conf, which should be present inside the files subdirectory under our role Apache. So we've established that the file is there. Now we need to specify a destination for this file as well. Now this file needs to go in /etc/apache2/apache2.conf. So source is apache2.conf inside my file subdirectory, and the destination is /etc/apache2 on the remote machine. And once this is done, I'm going to notify restart Apache. Now let's add the next task, and we'll call it deploy index.html, and here I'm also going to use the copy module, and source this time would be /var/www/html/index dot, oh my bad, the source would be our new index file, which is inside the files subdirectory. So this file right here, and the destination would be the destination path on the remote machine. So var www/html/index.html, and let's just save it. Let's put a space here and make sure that name and copy are at the same level, and the name here is at the same level as the name there, so we don't end up with a syntax error. Okay, now let's save it again. Now the next one is the services.yaml. Now in this file we are going to add a task to start the services. So -name starting Apache service. Let's add a few empty lines, and here we're going to use service, and name for that service is Apache 2. State is started, and let's save this one. Now in configure.yaml we had a notify statement to restart Apache. So inside handlers, in the main.yaml we have to specify a handler to handle this. So in the handlers main.yaml we will go in and we will type in name space restart Apache and service name is equal to Apache 2, state is restarted. 3 dots to finish this. Now let's do a save all. Now in the end we can also go into meta and then main.yaml, and here we can type in our own details. So I'm going to say I am the author. Description, I will say instructor. And the company name is optional, but I could say Labit. Now here I could specify things like main Ansible version, the platforms that are supported, the tags for this role, and some dependencies. So let's do a save all. So far we've configured a task to install Apache. We've set up a task to configure the new Apache server, and we've got 2 tasks in the configure.yaml file, one to deploy the custom apache2.conf file and the other to deploy the index.html file. Both these files are present inside the files subdirectory. Then we have a task to start the Apache services under services.yml. Now in the task section, let's go into the main.yaml, because obviously we will need to call these tasks as well, and here we will use include statement. So space include install.yml include configure.yml include services.yml. And that should be it. So let's do a save all, and let's try and run this role. Now to run this role, what we need to do is we need to just run the playbook to run this role. However, we haven't actually created that playbook yet. So we've got a role, we've got some tasks and a main.yml inside that role and some handlers and some other tasks, but we do not have any playbook yet which calls this particular role. So to do that, we need to go at the Ansible level and create that playbook that calls the role. Now we are going to call this install Apache using roles.yaml. Now in this playbook we will specify first the set of hosts that we are going to run this playbook on. Then we will specify the tasks. So actually we do not need to specify tasks, we need to specify the role. So and under roles we need to specify double dot slash roles slash Apache. Now what does this double dot mean is go 2 levels up. So if I show you the tree structure from Ansible, and this is important for you to understand. So we've got our Ansible here. Ansible is here, and we have our playbook install Apache using roles here. So 2 dots will take it to Ansible and then in roles, and then it will look for a role called Apache. Now we can just close this like this, and we might also add become yes. Now let's save everything and let's run this. So inside Ansible, now we can type in Ansible Playbook install starts with a capital I, so we'll use that. Apache using roles.yaml, and let's hit enter. Now so far so good, it has started the execution of this playbook, which means we do not have any syntax errors. Now here with this task, it has actually gone to find the role called Apache, found it, and installed the Apache server. Then it has gone in and deployed the custom Apache 2 config file from our config.yaml, and then it has deployed the new index file. Then it has started the Apache service, and then because we called for a restart if we change the Apache 2.config file, it has used the handler to restart the Apache service as well. And now we've got an OK is equal to 6 and changed is equal to 3. So if I was to go back to the dev machine now, and if I just hit refresh, now you can see that the new index.html was deployed. So this is how you can use roles. I will just do a quick recap because this was a big lecture. Now let me clear this first, and let me do a tree. Let me first cd and do a tree on Ansible. So what we did in this lecture was we first created a role called Apache inside a directory called roles. Normally in production environments, you will see a directory called roles, and all the roles would be defined under this directory. So we had a roles called Apache. Then under the tasks subdirectory of that role, we had a file called main.yml that called three files: install, configure, and services. So main.yml calls install, configure, and services. Install was used to install Apache. Configure was used to deploy apache2.conf and index.html file onto the remote machine. And then services was used to start the Apache services on the remote machine. Then we had a notification using a notify method inside the configure.yml file to restart Apache, and we inside our handlers we added tasks to handle that notify, and the task was to restart Apache using the service module. Then we also edited the main file inside meta subdirectory to add some metadata to this role, for example the author name, company name, etc. After we'd done all this, we went one step up and we created a playbook that calls this role. Now inside this playbook, which was inside the Ansible directory, we gave it a set of hosts to run the playbook against. We gave it root privileges, and then we called a role and we said roles and called the role Apache. The first two dots and then a slash will tell the system to go to the level of Ansible, and from there look for a directory named roles, and there inside the directory named roles go and look for Apache. So go to the level of Ansible, inside Ansible look for roles, and then inside roles look for Apache. With this we have come to the end of this long lecture. I hope you've understood roles. If not, just ask any questions and I will be happy to answer your questions. I hope you enjoyed this lecture. I will see you in the next one. Bye.
If you like this video, please subscribe to our YouTube channel.